All right, cool. Welcome, everybody. My name's Ken Hoff. I'm talking tonight about unit testing React components. We're just going to go ahead and get started here. A little bit about me. I graduated from CU, did computer science, graduated 2013. I worked for Microsoft out in Seattle for about 2 years. I was a program manager on Azure Active Directory, which is as big and boring and corporate as it sounds. Currently, I'm doing full stack web dev consulting and services based out of Boulder, Colorado. I usually work with emerging startups, startups that don't necessarily have any technical talent just yet. Usually that means building MVPs, things like Facebook for Dogs or Craigslist for Bongs. That was one that I actually ended up building, which was kind of fun. I teach introductory front-end web dev classes at a co-working space in Boulder called Spark Boulder. You can find out more about me and my work at hoff.tech. Fun fact about me, I just bought an old VW hippie van and I'm fixing it up to go visit all of the US national parks next August. So if you need an excuse to come up to talk to me after the session and you don't know what to ask, you can always ask me about that because I love talking about that. Tonight's agenda, 30 minutes, I'm going to try and talk about this. There is a ton of necessary complexity in this talk. I'm just going to try and rip through it. I tend to talk pretty fast. Then I'm going to have 5 to 10 minutes afterwards for questions. Oh, if you want to have a look at the slides afterwards, you can go to hoff.tech/slides/DenverScript. I also posted the link to that in the meetup. Things that you should already know going into this talk, or if you're going to get the most out of this talk. How to build a simple React component using things like props and state and what the component lifecycle is. How to transpile a React component into regular old JavaScript. If you're using Babel, that's fine. If you're using a bundler with Babel presets and plugins, that's also totally fine. It's nice to know general basic testing practices. What are your edge cases? What are your ideal cases? What are your error cases that you should be testing all of those things? I'll talk a little bit about spies and stubs and mocks, but you probably don't need to know about that for this talk. Things that we're going to learn tonight, we're going to learn how to render your React components into a synthetic DOM. We're also going to query the synthetic DOM so that you can understand what the React components actually rendered out to the page, what HTML elements now exist on the page. And we're going to talk a little bit about stubbing and mocking out other libraries and frameworks that are used inside of your components. Things that we are not going to focus on tonight, advanced testing practices, like super advanced spies, stubs, mocks kind of stuff. We're not going to talk about that. I'm not going to teach you how to write super complicated React components. We're going to be using a simple to-do list component tonight. Configuring Webpack in wild and wacky ways, things like tree shaking, which I did not know existed. So you guys can learn about that later. And we're not actually going to talk about React-specific testing frameworks here. React shallow rendering has been around for a while. Jest has sort of made the rounds, and Enzyme is sort of the new kid on the block there. But we're not going to talk explicitly about any of these. Sort of summing everything up, the way this entire talk works, I think the Enzyme documentation put this together pretty well. You don't have to read this whole thing. I'll just get snippets of it. Full DOM rendering is ideal for use cases where you have components that may interact with DOM APIs. DOM APIs in this case, we're talking about browser APIs, document.createElement, document.getElements by tag name, that sort of thing. Full DOM rendering requires that a full DOM API be available at the global scope. This is sort of the crux of testing your JavaScript components on the front end, making sure that the appropriate frameworks, libraries, and components are available at the global scope. Pretty much this entire talk is about managing global scope and what's available at the global scope. You can use these techniques that I'm going to talk about tonight to test any kind of JavaScript app. You can use it to test React apps, Angular apps, Vue.js apps, any other kind of JavaScript apps you want. Plain old JavaScript apps, they all should work. However, most of the big libraries and frameworks ship with their own specific testing utilities. First thing, we are going to make a quick to-do list app. I'm just going to copy and paste a bunch of code in here just to show that we have it all working, and then we're going to go ahead and test it. First things first, we're going to get our index.html right here. I'm going to create a new index.html. We got our mounting point right here. This is where our app goes. We're going to include our app.js bundle right there. We're going to use a dirt simple Webpack config for this, just nothing too fancy here. Config.js, going to post that in. It's going to hit the entry point that's in source app.jsx, and it's going to spit out build app.js. We haven't created app.jsx. That's what we're going to do right now. We're actually going to render our to-do list component onto the page. We're going to grab this bit right here. I'm going to create, let's see, source app.jsx. This is just like, React 101 rendering our component onto the page at this point. We haven't actually created our to-do list React component just yet, but that is what we are going to do now. Here's our to-do list React component. It's kind of big, bigger than it should be, but we are going to use that to-do list React component.jsx. I'm going to paste this in here. I'm going to build everything real quick, so we're going to do Webpack. We're going to set it up to watch, just so it updates every single time. We're going to have a look at the to-do list React component, then we're going to just briefly go through how it works here. Inside my index.html, we have our to-do list right here. If I blow this up, I'm going to add a new to-do. I can remove the to-do. I can add a couple to-dos. I am obviously not doing input validation here, but I can click and remove all my to-dos just like that. When I am working on my to-do list React component, all of the to-dos are stored in state. These are just strings, nothing complicated here. Each one of these to-do list items, when it gets rendered, also includes a button, which has a callback, which removes the to-do. One thing to note here is that I do kind of mix ES5 and ES6. I generally prefer ES5 stuff just because it's a little bit simpler for me, but I will end up using ES6 arrow functions later on, just so if you're looking at the code, keep that in mind that I do kind of go back and forth here. Then at the bottom, this is something we should have a look at in the form. I'm using a controlled input component here so that the value of the input field is actually managed via state. Every single time that changes, we update the value, and that gets reflected back when we render the component. So they are controlled components, but I am using refs here. And keep that in mind because we will need to deal with that later when we are actually testing this component right here. Moving right along, does it work? Yeah, it does work. That's good. Hooray, it works. Next thing, what we don't want to do is we want to test our to-do list component. And so the way I sort of think about this is that if I had written a to-do list class in JavaScript, just a plain old class in JavaScript, and I instantiated a new object of that class or whatever, and it had a bunch of member variables and functions and methods, I could hook into that pretty easily with Node and just test all that stuff. I could call the appropriate methods on the class. I could verify that the appropriate member variables have all of the appropriate things in them. It'd be pretty easy to test. But because this is a React component and React makes a bunch of calls to the browser API, things like document.createElement, document.getElementsByTagName, React is going to throw all sorts of errors when it doesn't have those functions available to called. Way back when in Web 2.0 development or whatever, if you were working at some company that was building a large app and you might have already had some kind of test pipeline set up for this kind of thing. You probably would have had a computer running Firefox or a headless browser like Phantom.js. You would have Selenium hooked up. It would be connected via a port, I think, to the executable headless browser that you had, and then you had to integrate your code with Selenium so that you could send click events into the headless browser and then navigate between pages. And I tried doing this a couple years back. I was doing a bunch of web scraping, and I've just never, ever been able to get it to work. It's just, I think I got it to work like once, and then I wasn't able to get it to work consistently. It was just sort of a pain, and I never really touched it again until I started having to test front-end components with React. So what we're going to do is we are going to create a fake browser API. Whenever the React component mounts, renders, etc., it makes calls to the browser API. It calls document.createElement, document.getElementsByTagName, etc. What we can do is that if we can just fake out each one of those methods, then React isn't going to crash anytime it tries to call all those methods. This is nice. Keep in mind that there are many, many browser API methods, hundreds and hundreds of browser API methods, so that might be a little bit daunting. But the other thing is that we would want subsequent browser API method calls to reflect what we did previously. So if we call document.createElement, and then we call document.getElementsByTagName, we're going to want to get back the element that we created or we appended to the page or however you want to do it. And what this means is that we are basically building a browser, which I don't get paid enough to do yet, so we're going to find another way to do it. Enter JSDOM. JSDOM is JavaScript Document Object Model. It is basically a one-to-one implementation of a browser, just entirely done in JavaScript. We call document.createElement, and then we call document.getElements by tag name, and we get back the element that we just created. JSDOM doesn't render anything, it's totally headless, just runs in JavaScript. It just sort of manages the state of the browser at any given time. Because it's all written in JavaScript, it's super easy to download from NPM, and the important thing is that it plays super, super nicely with all of our Node code. Which is the way that we're going to be doing all of this testing here. So what we're going to do first is we're going to set up JSDOM real quick here. Inside of our test directory, this is just plain old JavaScript function here. Let me create a new test/setup JSDOM.js right there. Go ahead and save that. I borrowed this from another blog post, so credit is on the code right there. All this does is this initializes JSDOM with a little bit of HTML, sort of provides the mounting point for our React application. There's a couple other things in here. We're propagating all of the window member variables to global, so that, or to the Node global objects, so that way when we're running our code inside of Node, all of the global methods can be called without any kind of issues there. What we're going to do is we're going to test this with Mocha real quick. Hopefully everybody is somewhat familiar with Mocha. All I do is I run Mocha. Mocha runs all of the files in the test directory. It says setting up JSDOM, done setting up JSDOM, nothing passing, we haven't written any tests. This is actually what we want to see here. If we were to console.log out window or document or anything like that, then we would see a bunch of browser API methods and variables. Maybe scroll X, Y, console.log would be an actual function. Well, I guess that is in Node too. Whatever. I think you get the idea there. Next thing we want to do, and this is where it gets kind of complicated, is we want to put our to-do list React component into that JSDOM document object model there. Theoretically, we could use react.render, which is how we normally render our React components to the page. But React gives us a bunch of React test utils, which make things a lot easier. I actually need to use these, which I haven't been able to figure out why, but we can talk more about that later. What we're going to do is I'm going to create a separate directory called test.jsx, because we're going to have to bundle this stuff up. We're going to take all of our little test code right here. Let me go ahead, create test.jsx, JSX. What was I calling this? To-do list React component, to-do list React component.jsx. What this is going to do is this is going to test. First, this is going to render our to-do list React component into our fake DOM, and then it is going to check and see. Actually, no, it's not going to test anything just yet. It is just going to render the component into the DOM. We require the actual React component, and then we use React test utils, render into document. We don't actually have to provide a mounting point because all of the DOM methods are available in the global scope right now. But the thing with this is that it is JSX, which means that it needs to be transformed back into actual JavaScript. And because we're also running it with React, we're going to need all those React methods available too, which means we're going to need to bundle React in with our test bundle here. So I'm just going to go ahead and create a second Webpack config here, which is probably the most awful way to do this, fair warning. Webpack.test.config.js. It's going to look basically the exact same, except instead of creating our application bundle, it's just going to create our test bundle here. I'm realizing right now that I misnamed something, so give me just a second here. This should be .test.jsx right there. Then I am going to come back over to my terminal here. I'm going to do, Webpack config, Webpack test config.js. We're going to build our test bundle. And then I am also going to go ahead and run all of the tests inside of our test directory. And we can see it's setting up JSDOM, done setting up JSDOM, renders the component into the DOM, and that all succeeds just fine. It might be possible to generate your test bundle with just a single Webpack config along with your application config, but I don't know enough Webpack foo in order to do that just yet. So I'll leave that as an exercise to the reader. Does it work? Yes, we were able to build it and we were able to run it just fine here. And this is where I talk a little bit about race conditions, because inside of our test directory, sorry it's a little small up there, we have set up jsdom.js and testbundle.js. The question is, what does Mocha run first? It runs them both, and it actually does not matter which order that we run them in. The reason that we'd be concerned is that if it tried to render in our to-do list React component to a DOM that didn't necessarily exist yet, which is created by our JS DOM, it would throw an error. But the way that Mocha works is that it just executes all the files, it runs all the JavaScript files, and then it goes ahead and runs everything inside of the test blocks that are defined by Mocha. So should work just fine as long as we are putting all of our rendering into the document within our Mocha test blocks right there. Hooray, it works. That's great. All right, now that we've rendered something into the DOM, how do we tell what we have actually rendered into there, and how can we verify that it is the right thing that we are rendering into there? I am going to go ahead and copy and paste this into my Mocha test block here. Sorry, the tabs are a little weird there. But we can see it renders an H1 with your to-dos, and then it uses assert.equal. React test utils find rendered DOM component with tag. This is pretty similar to document.getElements with tag name. It checks, we have to pass in the component that we just rendered. We check to see, or we pass in the tag name that we actually want to grab. We want to grab all of the H1s there. Because React is using its own little testing library, this doesn't necessarily, this operates a little bit differently than getElements by tag name. This expects there to be only one H1 on the page. If there are 0 H1s on the page, or if there are 2+ H1s on the page, it's going to throw an error. We are going to find that element. We're going to compare the inner HTML of that element with your to-dos. And if it works, then our tests go ahead and pass. Don't forget that you have to rebundle everything every single time. And then I go ahead and run Mocha again. It sets up JS DOM. It renders it in. And then it renders an H1 with your to-dos. Green check mark. We have now successfully tested our first React component on the front end. One thing to note here. I talk about this being similar to document.getElements by tag name, and so I tried using that. I tried using document.getElements by tag name, and for some reason I cannot get it to work, and I also don't know why I can't get it to work. So if you think that you know the answer and you want to show off your JavaScript skills, then shout it out during the question and answer section later so that you can show us. So cool. All right, next thing we want to do is that now that we've verified that we've rendered something, the correct thing, onto the page, we actually want to send clicks and key presses, maybe fill out some forms and hit some enter keys inside of our rendered React component. So what I'm going to do is I'm going to grab our next code block here, and this is where we are going to use refs. What we're going to do is we're going to check and see if adding a new to-do list item works correctly. What we're going to do is we're going to use refs. In this case, I'm not a huge fan of using refs. I always use controlled input fields wherever I can, but I haven't been able to figure out how to do this without refs. So what refs do is they actually sort of open the hatch and give us access to the underlying HTML element. So we can make all the browser calls that are attached to those to the HTML element class. This used to be able to be done with React DOM, but they deprecated that somewhat recently, so I haven't quite figured out the right way to go about this just yet. But we grab the actual HTML element in this case, and this is new to-do field. This is going to be our input text element. We're going to set the value of that input text element just like we would with normal JavaScript, and say this is a new to-do list item. And then we have to use React test utils to actually change the to-do field. We have to tell React that, hey, this field has changed, or otherwise it's not going to go through the process of updating all the appropriate state and that sort of stuff. So we have to tell it to change, and then what we're going to do is we're going to do a pretty similar thing to the form. We're actually going to grab the form element that the input text element is within, and then we are going to simulate a submission happening on that form. The user has clicked the button with the type of submit, or they have hit the enter key. In either case, it's telling React, hey, you have gone ahead and submitted the field. Then what we're going to do is we're going to find all of the to-do list items on the page. In this case, we're going to use React test utils again. We're going to use scry render DOM components with tag, which gets back a list of all of the this is basically get elements with tag name, but for some reason we have to use React test utils along with this. We check and make sure that the list of that, or the length of that list is equal to 1, and that the first item's inner HTML of that list is a span with the correct test plus a button, because I've also included it on there. So if I hop back over to my bundler here, I go ahead and bundle it one more time, and I run Mocha one more time. It goes ahead, renders it in, adds the new to-do list item, reads out that we have actually appended that to the page, and gives me a green check mark. Yes. Cool. All right. Now, the biggest Stack Overflow question is, how do I do this with jQuery? Because all of our components, maybe you're using jQuery to make AJAX requests or something like that. So we're going to add, on component did mount, we're going to query an open weather API that checks to see if we need to have a jacket today, or if it's cold enough that we need a jacket today. And if we need a jacket today, it's going to push a new to-do element onto the state, and it's going to bring a jacket in there. So I'm going to go ahead and pop that in real quick here. Back up here, component did mount, add a comma. It's going to check to see if data.main.temp is below 288 degrees Kelvin, because for some reason the API is returning it back in Kelvin. And it should refresh, and we'll see. I got an error, $sign. Oh, $sign is not defined. That's, baby's first jQuery error. Let's see here. Go ahead and paste that in. We're just grabbing jQuery from a CDN right now. Should rebuild automatically. And it says, cool, bring a jacket, because it's below 60 degrees. I think that was 60 degrees Fahrenheit. That was the right conversion there. Now, the problem with our JS DOM texts is that if I go back and I rebuild everything and I try and run Mocha again, it gives us $sign is not defined. Everybody's first JavaScript error. So how do we make that work? I'm going to do this in a really terrible way, but it gives you an idea of how it works. We're going to switch up the testing file a little bit so that I am re-rendering our component every single time that we run a test, which means that inside of a before each loop, I can see that I have rendered component. And you guys can see what's happening now, is that I actually define the jQuery global variable here to be an object with an AJAX method, which turns another object that has a done method, which yields to a callback that has main with temp of 0. So 0 degrees Kelvin, that should be pretty cold, which means that every single time our React component is rendered into our fake DOM here, we should get, it should put a bring a jacket element on there. I also have to remember to go back through and update all my previous tests because I am rendering in one element by default every single time instead of no elements. And if I go ahead and rebuild this real quick, hit Mocha one more time, then it adds bring a jacket to do after making a call to jQuery. Keep in mind that the actual test here is not anything different than what we've seen because we are changing the JavaScript global object to whatever we want every single time before we run any tests. So we just assert that, yes, we are actually rendering in bring a jacket here. This technically works. We have to adjust all of our other tests. That's fine. Our fake jQuery object, this is a terrible, terrible way to do it. This is a stub, or I would maybe technically call it a stub. If you want to get deeper into stubs, spies, and mocks, check out sign-on. Sign-on was incredibly obtuse and hard for me to learn at first, but now I basically cannot go without it. And there are much better ways to stub out jQuery objects in this case. You, savvy full-stack JavaScript developer, would also never be caught serving anything from a CDN, nor would you even probably serve anything from another script tag or anything like that. You would probably bundle jQuery in. But then that sort of raises the question, how do you override the jQuery file or the jQuery variable that gets imported into your to-do list React component when you build it with all of your other testing component utilities here? And that gets pretty hard. Best way I've found to do it is to use a library called Rewire. I won't necessarily go too deep, or I won't go into necessarily how that works, but it sort of replaces a require function, so that way you can overwrite member variables within your imported JavaScript files, which is pretty cool, but it also does not work with const. So you have to kind of make a trade-off there. Also, there might be times when you are rendering in a really, really big React component that renders out a bunch of subcomponents that you don't necessarily want to take the time to render out all of the subcomponents and the sub-sub-subcomponents and all that kind of stuff. Before, if I wanted to do this, I would have just used Rewire to just sort of mock out those fake React classes right there. But React Test Utils has recently gotten a mock component utility, so I would check that out if you're interested in doing that. Yeah. And then, of course, this technique is probably already obsolete in true JavaScript front-end fashion. Sorry about that. But now that you know sort of how it works, that we literally simulate a fake DOM every single time, It'll help you implement and debug this in the future. If you want to check out some libraries and frameworks to learn more about this, Ava.js is a test runner that I'm interested in. I don't know too much about it, and that's probably the next direction I'm going to go. And then also Enzyme has come out recently enough that I haven't played with it yet. And I think Enzyme actually bundles in JS DOM with everything else. I'm seeing some nodding heads, so that's awesome. So I would definitely check out Enzyme and figure out how to use that. Obligatory Hoftech pitch for me. If you know anybody that needs an app built, I do that. If you want to grab coffee or chat about the industry or get some eyes on code, hit me up. I'm a freelancer, which means I don't get to hang out with other web developers all day, which is kind of sad. So if you guys want to come hang out with me all day, that'd be a lot of fun. And if you're looking for work, get in touch. I'm always looking for subcontractors with diverse sets of skills to help out with big projects. Hit me up at ken@hoff.tech. And that's all I got. Thank you guys so much. And now I'm supposed to answer questions. Yeah.
Is there any benefit to using JS DOM as opposed to trying to use like a browser's DOM, like Bleak or WebKit or Trident? I don't know how you use it, it's Chakra or something.
Okay.
Because there might be like something that you did that wouldn't be supported. Like if you're running IE11, it doesn't support Flexbox. Or for IE11 doesn't include array that includes, or I don't know.
Yeah.
It's like JS DOM. It's kind of like it's good stuff to work, but like sometimes that might not work in like an actual.
Yeah, the question, I'm going to repeat the question for the mic here. The question was, is there any benefit to using, or is there any particular benefit to using JS DOM over using like an actual browser or some other more browsery simulation of a browser? There will never be a replacement for pulling up your code in an actual browser. There will never be a replacement for you installing IE8 on whatever machine you have and trying to pull up your site in that. I will say that the benefit for using JS DOM over using like actual browsers like that is going to be speed. It's going to be you not having to deal with all of the other cruft attached with an actual binary executable browser, a full browser in essence. Every single time you write a bit of code and hit save, and your Webpack watcher whatever goes through and rebuilds your entire application and also runs all of your tests, then that's where JS DOM comes in really handy because that goes really fast. Then again, of course, if you're using like Browser Stack or something like that, totally invaluable. Like if you have like, oh yeah, I'm pushing a new build out tonight, then Browser Stack actually runs and sends you the appropriate screenshots, and there's no replacement for that. But I would say that the huge benefit for JS DOM is speed there. Yeah, good question. What else?
Have you done much testing using like Axios, like having to test the fetching, using like a mock adapter for it?
Have I done much testing using Axios and the fetch adapter? I don't actually know what Axios is.
It's a library for handling like fetch. It's another like basically your $.Ajax from jQuery world. Oh,
you're talking like isomorphic fetch and that sort of thing?
Not necessarily isomorphic, but
okay.
Yeah.
Okay, yeah. Mocking out isomorphic not isomorphic fetch, just general fetch is pretty similar to mocking out something like jQuery. The only difference between them is like if I'm using $.Ajax, then I have to mock out that specific that specific method that I have here. So it would just be me replacing the fetch global method as opposed to the $.Ajax method. So it should work in concept pretty similarly. Sweet. Yeah.
You mentioned just briefly at the beginning that have you done any just testing?
I was not able to do any just testing. Definitely something I want to check out. I've heard that there is some problems with auto mocking. So I talked a little bit about mock components, and basically, I don't want to render all the sub components and stuff like that. Jest automatically does that for you, which is not anymore. Okay, cool. So that's changed, but okay, yeah, that's what I was hearing is that auto mocking was going to be an issue. So that might be something to think about. Regardless, like when I was using Jest, I don't think, or when I looked at Jest, I don't think I knew about JS DOM, and I like didn't fully understand what was going on here. So now that I understand, that I need an actual DOM, I might go back and try Jest again.
Jest actually comes with JS DOM now.
Sweet, Jest comes with JS DOM now, so that works out well. So you guys might not even have to do any of this. Awesome, cool. Well, thank you guys so much. I had a huge amount of fun.